The IPv4 addressing. IP addressing. We come now to classless interdomain routing, CIDR for short. The first approach developed for improving the addressing scheme is called classless interdomain routing, which is written as CIDR. This retains the concept of a net ID and a host ID, but removes the rigid structure and allows the split between the net ID and the host ID to be varied to suit individual need. The simple method used to achieve this is to add an 8-bit suffix to the address that specifies the number of bits for the net ID. So suffix means post, behind, after, right? Suffix. What is coming in front is called prefix. You know about that, no? Prefix, before. Afterwards, if something is at the end, then it's suffix. Add at the end, suffix. Add at the beginning, prefix. So this is the what you are using. The strategy here is add 8-bit suffix to the address that specifies the number of bits for the net ID. If, for instance, we define the suffix as 21, that means that 21 bits are used for the net ID. And there are 11 bits remaining, that is of a 32-bit address, to specify host IDs allowing 2 to the power 11. That is, here you have, now this is the net ID. The net ID is here, and you add 8, and the value of this is, let's see, 1, 2, 4, 8, 16. 16 plus 4 is 20. 20 and 1 is 21. If define the suffix as 21, that means that 21 bits are used. So this says 21 bits are used for the net ID. For this, how many are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So that is what it says. Out of this is not colored. This is colored only for ease of use, ease of learning. So these 21 bits is the net ID out of this whole thing. Altogether, how many? There should be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. So 11 and 21, 32. So 32 bits here, right? Out of the four bytes, we know that there are 4 bytes and a total of 32 bits. Out of that, this says 21. The value of this is 21. The first 21 bits are taken as the net ID. And there are 11 bits remaining. That is this 11 of a 32-bit address. If this is 32-bit address, that is IPv4, then 21 gone for the net ID, the balance 11. To specify host IDs, right? The host IDs can be these 11, allowing 2 to the power 11, that is 2048. 2048 hosts. With these 11 bits, you can go up to 2048 hosts, different addresses. One example of an IP address using this scheme is shown in figure 2.06. 2.06 CIDR IPv4 address. The 21 bits representing the net ID have been highlighted. These 21 bits highlighted. The remaining 11 bits represent the host ID. So these 11, the 11 bits here is the host ID, which would therefore have the binary value. This is the value, right? That's a host ID. It should be noted that with this scheme, there is no longer to use the most significant bit or bits to define the class. Allow already existing class A, B, or C addresses to be used with suffixes 8, 16, or 24 respectively. Classes A, B, and C again. Okay. Class A, the number of bits there is corresponding to this. 8, 16, or 24 respectively for the suffixes. Suffix is the one that is in behind. Task 2.02, create an example of the binary code for a class C address expressed in CIDR format. Give the corresponding dotted decimal representation. Subnetting. A quite different approach, subnetting, allows further structure in the addressing. To illustrate an example of this, we can consider a medium-sized organization with about 150 employees, each with their own computer workstation. Let's assume that there are 6 individual department LANs, local area networks, and one head office LAN. Figure 2.07 shows a schematic diagram of how the LANs would be connected to the internet if the original scheme were used. It's a diagram. The organization would need 7 individual Class C net IDs. Each of these would point to one of the LAN gateways, excuse me, which have to function as routers. Each net ID would be associated with 256 hosts. So an organization with just 150 computer workstations would leave 1642 IP addresses unused and unavailable for use by any other organization. So there is one gateway, to the head office LAN, and the other LANs are LAN 1, 2, 3, 4, 9. These are the gateways. Then this is the internet. Connecting LANs using the original classful IPv4 scheme. So what is this? What does this mean? Each net ID would be associated with 256 hosts, right? Each net ID, because net ID 1 byte let's see that there are 6. Yeah. So the byte for that is 256. You can have organization with just 150 computer workstations. There are only 150 computer workstations, but 256 hosts allocated for that, which no one else can use. Only this company can use 256, but they have only 150 workstations. So it's a waste. The subnetting solution for this organization would require allocating just one class C net ID. For example, the IP addresses allocated might be 194.10.90 to 194.10.9.255, where the net ID comprises the first 3 bytes represented by the decimal values 194.10.9. Right? The subnetting now works by having a defined structure for the 256 codes constituting the host ID. A sensible solution for this organization is to use the top 3 bits as a code for the individual LANs and the remaining 5 bits as codes for the individual workstations. Figure 2.08 shows a schematic diagram of this arrangement. just one router and these are connected. So you are saving that much. Subnetting, using subnetting. On the internet, all of the allocated IP addresses have a net ID pointing to the router. The router then has to interpret the host ID to direct the transmission to the appropriate host on one of the LANs. For example, host ID code, this one, could be the address of workstation 14 on the head office LAN, LAN 000, this one. Host ID code, this one, would be the address for workstation 16 on LAN 3. On this LAN, the 16th workstation. So that is LAN 011. 11 is 3. No? This is 00001. 010. This is 011. Only just 3 digits. No? Just need 3 digits to use as a code. Okay? First 3 bytes. Okay? Comprises the first 3 bytes. And just 3 digits using for this kind of thing. So that this will be 001, 010, 011. So it's easy. The LAN label is 011. Just 3 bits used. With 150 workstations, the organization has used all of the 256 allocated IP addresses. So even if you have 150 workstations, that byte is allocated for them. You can't have it for another company. However, there are only 106 unused, which is a reasonable number to have available in case of future expansion. So that also you have to consider. Now, when you deduct 150 from 256, there are 106 only remaining. So for an organization of that size, there is a possibility, a very likely a possibility, very good possibility of expanding it. So you need more and you don't know how many. So this is all right, reasonable for future expansion. Then NAT, Network Address Translation. The final scheme to be considered is different in that it deviates from the principle that every IP address should be unique. That we know the IP address should be unique, otherwise the whole idea is lost. In this scheme, provision has been made for large organizations to have private networks, which are called intranets. Intranets. Normally, the private networks are called LANs. The difference between LAN and intranet is an intranet is a LAN using internet technology. All right. If a local area network uses the internet technology for that network, then it's called an intranet. Meaning it's like the internet, but it's internally, intra. And if that is connected to the internet, then that is called extranet. It's not mentioned here. It's not coming under this one, but for your knowledge, extranet, which use the same protocols as those used for the internet. All right. So that's what I explained. Protocols used for internet. So you're using the same thing. You can have web pages, you can have email, everything, but within that intranet only. It's like a small internet within your organization. One justification for using a private network has always been that this provides extra security because of the isolation from the internet. That is self-explanatory, no? It explains itself. When you are connected to the internet only, there are many dangers. But if you have your own private network, those dangers are eliminated. However, this is no longer normal practice. Organizations want private networks, but they also want internet connectivity. They want to connect to the internet also, like an extranet. The solution for dealing with the addressing is to use network address translation. NAT, network address translation. Figure 2.09 shows a schematic diagram of how this can be used. The NAT box has one IP address. Okay, this has one IP address which is visible over the internet, so can be used as a sending address or as a receiving address. Internally, the IP addresses have to be chosen from one of the three ranges of IP addresses shown in table 2.03. So the here IPv4 addresses to be used in private networks. So it's allocated in private networks. You can use these. The lowest is the 10.0.0.0. Then in that range, then the maximum is 255, 255. Then another one is 172. They are also 16.0.0. They have up to 31. Then 192.168 up to 255. The maximum. These two are maximum 255. That have been allocated for such networks. You do not need to remember these numbers. So it's a relief. No, you don't have to remember these. The important point is that each address can be simultaneously used by any number of different private networks. How is that? Like this 172.31.255.255 is used by maybe the Sampath Bank, Nugegoda. They are in their office, this will be used. Then the same address is used in another, say, architect company, architect or building contractor or doctor's dispensary or anywhere. You have the same thing there. How can that be? Because normally in the internet, one IP address is very unique. This is because they are not connected to each other. In one network, this is unique. The doctor's network, same thing. This one is unique there because they are not connected. The bank one and this one are not connected, so there is no clash. Private networks. All right. Uh, there is no knowledge of such use on the internet itself or in any other private network. The interface in the net box has software installed to examine each incoming or outgoing transmission. There can be a security check before an incoming transmission is directed to the correct internal address. Security check before addressing it to the individual, that private thing. Correct internal address. The diagram shows undefined arrows from the outer connected to the net box. From the router connected to the network. These indicate that the network structure within the organization could take many different forms. Discussion point is, can you find out which IP addressing scheme is being used when you are connected to the internet? All these can be done through the Google. When you search, you will get various websites dealing with each of these issues, problems or topics. Then we come to IPv6 addressing, that is Internet Protocol version 6. V6 is version 6. Today there are combinations of IPv4 approaches in use, and these allow the internet to continue to function. Respected sources argue that this cannot continue beyond the current decade. There must soon be a migration to IP version 6, IPv6, which uses a 128-bit addressing scheme, allowing 2 to the power 128 different addresses. A huge number. So 6 is version 6 is using 6 bytes. No? 6 bytes into 8 is 128. Correct? Yeah. When you multiply 8 by 6, sorry, 128 by what is that? Yeah, 6 bytes by 8. 128 100 uses a 128 bit addressing scheme. Then addressing scheme it allows 2 to the power 128 different addresses. Correct? A huge number. In practice, this will allow more complex structuring of addresses. Documenting these addresses is not going to be fun. The addresses are written in a colon hexadecimal notation. The code is broken into 16-bit parts, with each of these represented by the hexadecimal characters. Unfortunately, some abbreviations are allowed. A few examples are given in table 2.04. Can you see the format? So the 16-bit parts, right? 16-bit parts. That is how we get this 128 also, like 16 bytes. 1, 2, 3, 4. Like if you count, that's a full address. Full address. 3, 4, 5, 6, 7, 8. 8 into 2. Like 6 is, say, there are 4 digits. 4 hexadecimal digits means 16 bits, because now 68, like for example FF, if you take FF, that is 8 bits. No? F is 1111 in binary, another F is 1111, so total of 8 bits. For 1 is 4 bits. For one hexadecimal digit, you need 4 bits. Is that clear, Sulaksha? For one hexadecimal digit, you need 4 digits, like that. So here is 4 means 16. 16 digits, 16 bits. So like that, 1, 2, 3, 4, 5, 6, 7, 8. So 8 into 16 is 128. That's a full address. What is this? Has been replaced by this, the colons, the 2 colons. These zeros, these 2 have been replaced by 2 colons here. Then leading zeros omitted. So the leading zeros omitted, you will get like this. And an IPv4 address used in IPv6. So these are normal format, IPv4 address. You have to indicate like this. Right? So those are blanks there. Leading zeros omitted. Those are blanks. These are some examples of IPv6 addresses. We are not using it yet, but it's predicted that at the turn of this decade, that means after 2020, it will be needed because the population is expanding. At the moment, about 4 billion users. So more than that, you need 4 bytes is not enough. That is the idea. Extension question 2.01. If IPv6 addressing is used, how many addresses would be available per square meter of the Earth's surface? Do you think there will be enough to go around? That's interesting. If you can do the calculation, go to Google and get the information, square, the area and everything. And we come to an important section 2.08, domain names. In everyday use of the internet, a user needs to identify a particular web page or email box. The user will not wish to have to identify an IP address using its dotted decimal value. To get around this problem, the domain name system, or the DNS, was invented in 1983. The DNS system allocates readable domain names for the internet host and provides a system for finding the IP address for an individual domain name. If not for this, you will have to type the address, the URL address, in hexadecimal format. Domain name system, a hierarchical distributed database installed on domain name servers that is responsible for mapping a domain name to an IP address. A domain name is given for every IP address, or rather the other way around. An IP address is given to all the domain names. The system is implemented as a hierarchical distributed database which is installed on a large number of domain name servers covering the whole of the internet. The domain name servers are connected in a hierarchy. Hierarchy is like top to bottom, the order, with powerful replicated root servers at the top. The main ones of the hierarchy supporting the whole internet. DNS namespace is then divided into non-overlapping zones. Each zone has a primary name server with the database stored on it. Secondary servers get information from this primary server, like a tier basis. First tier, second tier, like that goes on. As a result, the naming system is hierarchical. There are more than 250 top-level domains which are either generic, that is .com, .edu and .government, or represent countries, example .uk, .nl, .lk, like that. The domain name is included in a universal resource allocator. We say universal resource locator. Right? We say locator. So this is the resource allocator, which identifies a web page or an email address. Either a web page or an email address. A domain is named by the path upward from it. For example, .eng, eng.cisco.com refers to the .eng subdomain in the Cisco domain of the .com top level domain, which is the reverse of that used for a path name of a file. Looking up a domain name to find an IP address is called name resolution. Like how to find like an IP address. The IP address is there 192.168 or something like that. Finding the name of that. The name resolution, that's called name resolution. For such a query, there are 3 possible outcomes. If the domain is under the jurisdiction of the server to which the query is sent, then an authoritative and correct IP address is returned. If the domain is not under the jurisdiction of the server, an IP address can still be returned if it is stored in a cache of recently requested addresses, but it might be out of date. If the domain in the query is remote, then the query is sent to a root server which can provide an address for the name server of the appropriate top level domain, which in turn can provide the address for the name server in the next lower domain. This continues until the query reaches a name server that can provide an authoritative IP address. So this is the kind of thing which will find the correct IP address. Like when you type an URL, it is connected to a IP address. So we can't remember. We don't know that, or it is very difficult to remember and type it. Even if you remember or write down and keep to go and type it in that way, it's difficult because there's no meaning. But whereas if you type like Sri Lanka online school, it's very easy to type. You don't have to think the spellings and the sound and everything. It's very easy rather than typing A, C, D9, 48. How to remember those things? There's no meaning in that. This is going to be very interesting and also practical. You have to get involved. 2.09 scripting and HTML in a client server application. So scripting is like there are script languages, the JavaScript and various things, and HTML, hypertext markup language we have done. In a client server application means server is the web server and the client is the user. In that, what we are going to do with this scripting and HTML. It is possible for an individual to create a client-server based web application for personal use on an individual computer. This would require downloading appropriate server software, installing the application and using the computer's browser to access the application. However, a better understanding is gained by considering a scenario where a developer has created a web application and made it available for use by remote users. So how is it going to, how are you going to make that available for the remote user? The application developer has to create the application as one or more web pages. This is a three-stage process. Firstly, for each web page, a file has to be created which is written in HTML. So firstly, for each web page, a file has to be created which is written in HTML. Secondly, a domain name has to be obtained from a web hosting organization. So you have to pay and get a domain name. Finally, the HTML files have to be uploaded to the server provided by the web hosting organization. The following is a simple sequence of events associated with the user accessing the application. Actually, this is what has happened in this website also. This is the domain name and I have paid for it. I have paid for this domain name. Then I have paid for hosting. Host this at a third-party web server so that it is available to the whole world on the internet. And then I upload my files here so that when you type the URL, you will see it. The HTML files have to be uploaded to the server provided by the web host. The following is a simple sequence of events associated with the user accessing the application. The user opens up a browser on the client. You can do that now. Just go and click this, you get the browser open. The user types in the URL of the web application or selects it from the bookmark list. The browser asks the DNS system for the IP address. So I type the URL, the user types the URL in English, but the browser asks the DNS system. There is a DNS system. The browser will look after that part. We don't have to worry about it. We don't have to know about it. But the browser will ask the DNS system for the IP address. Can you give the IP address for this srilankaonlineschool.com? Then it will get, the browser connects to the IP address and sends a request for the web page. So then only the browser will connect to that particular IP address and then sends a request for the web page. The page is sent by the server to the browser. So the server, which has on its hard disk all the HTML files and other JavaScript and PHP and various other files, picture files, video files, whatever it is, this particular page. The page is sent by the server to the browser. The page that we requested by typing this IP address, rather the URL. We type the URL, but it is translated into the IP address. Then the web server will send this page to the browser which is the client computer. The browser displays the page. This is the sequence of events. Once a page is displayed, the user can activate the application by clicking on a suitable feature or by entering data as appropriate. So that page will have a link or a button. When you click, that application will work. That is how internet programming is done. How you can access a program on the internet. And this is HTML. We now need to consider the framework for creating a file using HTML. This is a text file constructed using pairs of what are referred to as tags. The basic overall structure can be represented as, these are the tags. Basic tags which are with the label is within this two sets of opening and closing angle brackets. And you start with HTML, end with HTML. It's a pair of HTML tags. Ending is the slash. Same way, the head and ending of head. Body, ending of body. And with what is there inside this body will appear on the screen. In between each pair of opening and closing tags, there can be any number of lines of text. These can be used to display on the browser screen any or all of the following text, images, all of the following text, images, videos, fonts, hyperlinks, icons, and so on. The facilities offered by HTML can be supplemented by the inclusion of scripted code written in JavaScript or PHP. Before going to JavaScript, we will do a small HTML file. You may have done it before in last year, but then just a quick revision. You take a notepad and type same way you have the head is not essential. Body, close body. Inside the body will appear what you type here. What you type inside the body here will appear on the screen. Now you have to save it not as a text file but as a HTML file. We'll name it as HTML, has to be there as the extension, file extension. locate it now. Hello. Already it's showing that icon, no? The browser icon. So if I double click, it has come, hello world. And if I want to change something, say for example colors, we have done colors using the hexadecimal notation for colors. In the body, we can change the background color by saying bg color, body bg color, and you can't type color the English way. You have to type it this way. Cyan, a light blue one. Save it again and refresh this. Jaiva, how it changes the body color. Now you see that this is only in your hard drive. The D colon. Now if you type it from there, from your home, you will not be able to get this one. Supposing let's make it, you will give the class name also. Hello world. I can make it big. You don't have to worry about it now. Edit H1 lower 6. So that this will be a unique thing. And close the H1 heading. It's called H1 heading. Save it. Refresh it. But now if I copy this and give to you, or you copy this, because you can see the screen. If you run it, if you type this on your home computer browser, nothing will happen. This will not come. Something else, if it is there by this name, it will come. Otherwise, say file not found. So how do you get it to internet, and you can give another person the URL. I will show it with my own website. I have to go to the host control panel. Very slow, especially when you have the remote access for Zoom. Computer becomes slow. All right, I have to log in. The waiting is worthwhile because you will have an idea as to how exactly this works. Still, you can't access this page. So very soon I'm going to upload it to this server and make it available to the world. I have the file management system here, file manager. And I select, I have two domains. I select this one and yeah, public HTML, that's the one, the root. Here I can upload to this directory and select files from my computer. Yeah, model. Yeah, it's hello. Upload. Done. And you can see it here. See, this is the file. If you want to see the coding, select it, edit. See, this is what we type, the lower 6. Here there's a mistake here. I didn't notice it there, but this is save it, save and close, and let's go to www.srilankaonlineschool.com. In that main directory, hello, no, hello, hello, simple HTML put .html is all. Okay. When I press enter, there you are. It comes, but where is this? No, this is capital H. I have put simple. There is some other thing I translated. It turns on to capital automatically. So what do I do? Look for that and delete that. Here, 9th, on the 9th September for another class, I have done this demonstration. I will edit that. See, hello world, saved as capital H. So what I can do is I can delete it. I don't need it now. Delete. Now I make it simple H. Now if I put enter, what will happen? Not found. The 404 is the error code. There's error code 404 not found. Why? Because there's no file called spelled with capital H. But now there is one with simple H. Again has changed. There is some which I can't explain. Yeah. It turns to H. So this is, yeah. Now you need quick thinking. What am I going to do? I am going to change this to rename it to capital H. Make this to rename first, then run it. I'll just refresh because it is already capital H. See? Now, if you type this URL, now if you type this URL on your computer, you should see it. Yeah. Dilakshan, can you type this URL on your computer and see whether you get this? Just explaining how this our what was saved here. When you took it, it was just here on the hard drive. But I can't give this to you, you can't load it. Then I uploaded to my website here. It's called Hello H. And then it works. So you can type this, you can copy this, you can't copy, no? But just type this srilanka.com / and capital HELLO.html. See whether you get this page. Are you typing?
Yes, sir.
Yeah. Tell me when you get it. Are you not getting it?
No, sir.
You're not getting it. Can
No.
you share the screen?
1 minute, sir. So should I type that hello HTML thing also?
Yes. Yes.
Wait.
That's the web page name. Anyway, you can check it later. So I'll just show you again how we can do some change here. Earlier, I did the change here and saved, and then I uploaded. But now, instead of changing this here and uploading, I can straight away edit this. Now I'll change the color to another one. But so I will type St. Nicholas's. Over 6 SNIC, like this I'll type. And then the change should appear. Yeah. If I reload this, right, the background became yellow, and then the additional letter SNIC, the word SNIC came. All right. We can go up to JavaScript. JavaScript is written by the application developer into the HTML text, but its effect is to allow the user at the client end to interact with the application and to cause processing to take place on the client computer. For this to work, the browser must have JavaScript enabled. You may have come across this. Some applications, if you can't run it, it will say, please enable JavaScript in your browser. Or troubleshooting, uh, they might say, look whether your browser has enabled, you have enabled JavaScript in your browser. In the early days of the use of JavaScript, it was necessary to ensure this and to include explicit reference to the use of JavaScript in the HTML file. That is, we have to mention in the HTML file, this is the script where I'm going to use script and this is the name of the script language and all that. However, JavaScript is now the default scripting language. So a script runs automatically. The important point is that this has nothing to do with what is installed on the server. So it is running on the client's computer, and also you don't have to specify that it's JavaScript because it's standard now. If you're using something else, you might have to. If you're using some other kind of script. One way to incorporate JavaScript is to write the code in a separate file which is then called from within the HTML. Here we only consider the case when JavaScript code is contained within the HTML itself. This is easily done and easily recognized in an example HTML file by containing the script in script tags. So we can have a separate file for JavaScript and from this file, the HTML file, we can call it. But we are not doing that. In this, we are learning this way. In the HTML file itself, we have this script, start script, end script, like start body and end body, and the line of JavaScript code within that. If the developer wants the script to be accessed immediately when the web page is displayed, the script tags are included in the HTML header section. Then it has to be in the header section. I didn't do the header section yet to demonstrate what it is. We'll see what extent. Yeah, then comes PHP. That's another thing. So I will demonstrate the header again. You can have this. I'll go to the site and then do the change. Header always comes before body, yeah? Just like the neck, the head, then the stomach, like the rest of the body. Same way, we have the head here and closing head. There, when I type here, it automatically comes. Here, things like which doesn't appear on the page, on the main web page, it doesn't appear. There we can say, see what happens now. Title tag, it will appear there on this place here instead of the URL. Let's see whether it happens. Then closing head, yes. So at the moment, it's www and the domain name, no? But when I reload now, look at what I have here, lower 6. So that is the head, how the head works. Inside the head, there isn't anything. That what is inside the head will not appear on the web page. Yeah, in this place, we can put this coding. JavaScript is a full-blown computer programming language. So that's a language, not like HTML. HTML is not a computer language, it's a markup language. Below is an example script which indicates how easy it is to identify some JavaScript within HTML and to see what it is doing. It uses variables. You know about variables, no? For more information about the variable, to convert a temperature value input in Celsius to a value output as Fahrenheit. So it's like a small program. The input uses the prompt construct, which provides text to guide the user as to what should be input, and the alert construct, which displays an explanatory text with the output value. So if you want to input something, it's prompt. If you want to output, it's alert. So up to this is okay. Up to here, this is okay. Script. Here we are starting script. See whether we can copy and paste, and then we can change it. And the ending script here. Script, yes. Variable temp c equals. Just it looks it's okay. Only these inverted commas and all that is a problem. Yeah, there's a bracket missing here. Notice, like in Pascal, you need a semicolon to end the thing. So in the alert also, where is alert? There is no semicolon there. That's the last one. 32 is there. Okay. There's no bracket there. What did I do? Bracket. I'm sorry. Run it and see. Reload now, and the prompt comes here because of the prompt. Please enter the Celsius value. The answer is the Fahrenheit value is 212. So you want to run again, or you can even have a button. Zero. Okay. No? This is like a small program working inside the HTML. The question now is, when would a developer want to use JavaScript? The answer to this is whenever the developer wants the user to have processing carried out on the client computer. On the client computer, remember, like now PHP is different. Other thing. The JavaScript works on the client computer, which does not involve the software running on the server. So there's no overhead on the server, no work on the server. It will work on the client computer. This might involve running a program as illustrated by the above simple example. More often, the JavaScript is used for collecting data which is to be used by a program running on the server. In particular, data validation and verification can be handled using JavaScript. So, yeah, like validations when you input something, like when I minus thing or acceptable, then you can program it to say this is invalid or something for validation purposes. Any questions on that up to that? Because PHP we can do next time. You have to do practical, otherwise just listening to this and just waiting won't do. What you understood now, you have to do practically, and you don't need any software downloaded for this. Only the PHP, when you come next time, I will demonstrate that. This you need a website. On your computer, this will not work. That is the only problem. You can't do this unless you upload it to a web server. But JavaScript, HTML, these things you can carry out. You can practice on your own. All right. In Friday, yeah, CIDR, and we did up to next time it will be PHP. I'm having an exam today.
No,
Yes.
sir.
No? So this we have done. Right. So then we'll call it a day, no? That's enough for today, no? Okay then. Thank you very much for joining.
Okay, sir.